Hello, gals and guys, and happy Friday Eve, everyone. I hope that everyone is doing okay. And what's that? That's weird why the lights went out. I don't know what the heck just happened there. Look at this flashlight. Something weird is happening here. I don't know what the heck's going on. Did you hear that? What was that? What's that? Whoa, there's somebody else in here. Ah! Okay, so today's lesson actually isn't that scary. Today's lesson is on the normal distribution and not the paranormal distribution. So let's see what this is all about. So as with other lessons, right, today's lesson, you can find the worksheets up on Classroom. And so if you want to print them out, you can. If you want to take notes as I go through this particular topic. We have talked about different populations that for whatever one reason or another people want to perhaps examine and perhaps examine some data about that population. And sometimes when we collect that data, it the way that that data is distributed can be described by what we refer to as a normal distribution, or sometimes referred to as a bell curve. And so this curve right here kind of shows exactly how that all fits out, right? This sort of looks like a bell, and if this represents perhaps data for a particular population, there are certain tendencies that occur here. So right here in the middle of this normally distributed data, we see this, once again, this mu, which represents the mean of all this data. And the mean is directly in the middle here. And then spread out from the mean, we see these numbers 1, 2, and 3 above the mean, and then these numbers -1, -2, -3 below the mean. And those refer to the standard deviation, how far we are away from the mean. And so based upon how far we are above and below the mean, with normally distributed data, there's a certain percent of data that always falls within these distances from the mean, within these standard deviations away from the mean. And so when we go from one standard deviation below the mean to one standard deviation above the mean, we will always find with normally distributed data 68% of all the data in this population. If I can get that in there. There we go, 68% data. All right, and that'll always be true when you have normally distributed data. That 68% of that data lies within this range. Again, from one standard deviation below to one standard deviation above your mean. And then if we extend outwards from there, if we go look from two standard deviations below the mean, 1, 2, to two standard deviations above the mean, this length here, we will find that there is 95% of all the data lies within that interval there. And then for the last interval here, if we pretty much go all the way up to 3 standard deviations above the mean to 1, 2, 3 standard deviations below the mean, you'll find pretty much all of the data lies within that interval. And specifically, the percent there is 99.7% of your data lies on that interval. And this is sometimes referred to as the empirical rule because, again, with any normally distributed data, these are the percents of the data you'll find within each of these intervals. Okay, so now as you go and work on problems that you hear that you're dealing with normally distributed data, again, these percentages are going to play a key role in trying to answer those problems. So again, if you have a question that says, like in example 1 here, for a population that is normally distributed, find the percentage of the population that lies, well, A, within one standard deviation of the mean. Again, within one standard deviation of the mean, that's this interval here. So that will always be 68% of your data lies within that interval. And then the percent of the population that lies within 2 standard deviations of the mean, well, do this in blue. This falls again from 2 standard deviations below to 2 standard deviations above. That will always, you will always find 95% of your data lies within that interval when you're dealing with normally distributed data. And then for the last interval here, again, normally distributed data, the percent of the population that lies within 3 standard deviations of the mean, that will always be 99.7% of your data lies in that interval. And so when you are working, again, with any problem that deals with normally distributed data, these are the percentages that you'll always want to use. And the other thing I will say is that sometimes it's helpful to draw out your normal curve because you will not be presented with this in a problem, but it's nice to draw this out and actually, label your number line here so that you can determine exactly, what percent of data lies within certain intervals of that respective problem. And so with this now hopefully laid out for you guys, let's actually see this applied in an actual question. Okay, so now in example 2, we have at Arlington High School, 424 juniors recently took the SAT exam. On the math portion of the exam, the mean score was 540 and the standard deviation with a standard deviation of 80. The scores on the exam were normally distributed. Answer the following questions. So part A asks, what percent of the math scores fell between 460 and 620? So again, because the scores in this exam are normally distributed, what you typically would want to do in this type of a question to try to figure out, as in part A, what percent of the data of the math scores fall between these two scores, is I will just draw out, do my best to draw out a bell curve. And then from here, again, we know that the mean of the scores is always going to be directly in the middle. And the mean of your scores is going to vary from one question to the other. In this problem, we were told that the mean was 540. And so I'm just going to place that right here. And now, as was depicted here, right, we see increments going out from the mean by, one standard deviation. And so that's what I'll do here. But to list out what those numbers are, I'm going to use what the standard deviation is for this respective problem. And in this question, the standard deviation is 80. So when I go one standard deviation above this mean of 540, that standard deviation length has a value of 80. So this number here on this number line should be 80 more than 540, and that would go up to 620. And I can continue going, if need be, out further on this number line. So if I did another standard deviation up from 620 in this problem, would be 80 more than 620, which would be out to 700. And again, I could go out another standard deviation if need be, but because the maximum score here is at 620, technically I didn't need to label this 700, but I just want to do that just to show you, how you can progress up from the mean. But that's as far as I really need to go here for this problem out to the right. And then out to the left, again, we would go or label or go by increments of one standard deviation, but now we're going, to values less than 540. So 80 less than 540 would be 460. And technically, we can stop right there because the lowest score here is at 460. But if I wanted to go another standard deviation out or down from here, that would mean I have to go 80 less than 460, which would go down to 380, right? And so, right, however far you need to go below and above your mean, based upon that mean and standard deviation of your problem, you can label that out. But since we're only looking at scores between 460 and 620, I now see that on my normal distribution here, to go from 460 to 620, we are going, right, this is one standard deviation below the mean to one standard deviation above the mean, right? And we saw that the percent of our data that lies on this interval from one standard deviation below the mean to one standard deviation above the mean is 68%. And so that is our answer to part A. And then now for part B, how many actual scores fell between 460 and 620? And we're told to round our answer to the nearest whole number. Well, we know now that 68% of all the juniors that took the SAT exam, their scores fell on this interval. So to get the actual numbers, to figure out how many scores that we actually have here, we can just take 424 and we can multiply that by the percent, but just convert that percent into a decimal. And you can, do this calculation on your calculator, and I believe that when you do that, round it to the nearest whole number, that you will get that there were 288 actual students that had scores lying on this particular interval. Okay, so now let's look at another example that will involve normally distributed data. So example 3, we have the length of songs on the radio are normally distributed with a mean length of 210 seconds and a standard deviation of 16 seconds. And so then we're asked approximately 95% of the songs fall within what two lengths? Now, again, because we're told we have normally distributed data, the first thing that you typically want to do is just draw out your best job of drawing out your bell curve. And then from here, I'll start to try to label the number line here using the specific values that we're told in the problem. And here we're told in this problem, the mean value of this normally distributed data is at 210. So again, that goes right in the middle. And then we can, from there, calculate what these values are that go above and the mean by increments of 1 standard deviation. In this problem, the value of 1 standard deviation is 16. So going above our mean increment by increments of 16, well, this first increment here should be at 226. Right, that would be 1 standard deviation above the mean. And then the next increment from there, 16 more added to 226, would give us 242. Right, and then this would be this value would be 2 standard deviations above our mean. And now, not that you have to write this down here, but 95% of our data, when you see that in a normally distributed problem, we find 95% of our data when we go 2 standard deviations above the mean and also 2 standard deviations below the mean. So for this question, I don't need to really label anything higher than this here because this is as far as we need to go. But what I do need to do is I now need to go by increments below the mean. I need to go 2 standard deviations below the mean. So the first value, less than 210, that's 1 standard deviation below that, would be at 194. And then going another standard deviation below 194, that would be 16 less than 194, and that would be at 178. Right? And then so here we see we are going 2 standard deviations below the mean. And again, on this interval here, when we go from 2 standard deviations below the mean to 2 standard deviations above the mean, right, we will always find 95% of our data. And so between an actual length, song length of 178 up to a song length of 242 seconds, right, that is where we will approximately find 95% of the songs with those particular lengths in this particular problem. Okay, so now let's look at one last problem that involves normally distributed data. So in example 4, we see that the amount of soda in a standard can is normally distributed with a mean of 12 ounces and a standard deviation of 0.6 ounces. If 250 soda cans were pulled by a company to check volume, how many would be expected to have between 10.8 ounces and 13.2 ounces in them? Now, again, because we see that we are dealing with normally distributed data, I'll start off by just drawing out my bell curve, and I'll start to try to label the values on my number line that are specific for this particular problem. And again, in the middle of our normally distributed data should always go our mean. And in this problem, the mean value is 12 ounces. So I'll put 12 there. And then I'll start going above the mean by increments of 1 standard deviation. And in this question, a length of a standard deviation is 0.6 ounces. So we add 0.6 to 12 and we get 12.6. So that'd be 1 standard deviation above the mean. And I still need to go further because we got to go up to 13.2 ounces. So go another standard deviation above 12.6, add 0.6 to this, and we get 13.2. And then for this problem, I can stop there because that is the upper bound that I need to go for this particular question. And I now know that technically I have gone 2 standard deviations above the mean, but now I'll label below the mean as I've done in prior problems. So going by increments of 0.6, that is the length of one standard deviation in this problem. 0.6 less than 12 is 11.4. And I got to keep on going down from there because 10.8 is a lower value here. So another one standard deviation below 11.4, we subtract 0.6 from 11.4, and we get to 10.8, right? And that being the lower value, I don't need to continue going down any further. I see here that I've gone 2 standard deviations below the mean. And again, as in the other problems, and as with any of these questions, once you know how far you are going below and above the mean, we always know what the percent of the data that lies on there because of our empirical rule for normally distributed data. So we should see that between these two values of 10.8 and 11 and 13.2, we should find 95% of our data in this question. But we weren't asked specifically to find the percent of data that lies between these two values. We were asked to find how many soda cans lie in this interval. And to find that, we can take this percent along with the total number of cans and essentially just multiply that total number of cans by the decimal equivalent of 95%, which is 0.95, to get the total number of cans that actually should lie or expect to be found between these two values. And when we do that multiplication out, we get 237.5. And this being a multiple choice question, the value that's closest to 237.5 is this 238. And so that should be the number of cans that we would expect to find between these two values of volume of soda within these cans. Okay, so that's it as an introduction to normally distributed data and problems that involve applying that empirical rule of 68%, 95%, or 99.7% to any of these types of questions that involve normally distributed data. So I will post some problems for you guys to practice that empirical rule, and I'm not expecting you guys to hand it in or not requiring you guys to hand it in. I will post my solutions along with those problems so that you can check your work. And if you have any questions on any of those problems, please let me know. And just a reminder that quiz number 3, which I assigned on Monday, is due tomorrow, Friday, by 11:59 p.m. So please have your work, that quiz in by then. So good luck with that particular quiz, and also good luck for any of you who are taking any AP exams. I hope that they all go well, and you know that, well, basically that you do well in all those AP exams. So good luck with them. And I hope that everyone has a awesome weekend. And as always, please take care, stay safe, and I'll talk to you soon.